Hello guys and welcome to Physics Lover YouTube channel, and this is in front of you my new art of the channel. I think it's looking nice actually. This formula E is equal to mc square has a great significance in the world. It relates energy to the mass and speed as a constant. So I think it's good, and this is my different type of videos over here. I think published 10 questions right now of Irodov, and below there are my liked videos. So, today let's focus on question number 11th of this great book by the genius Irodov, and let's crack it. So, here in front of me is Irodov, and here is the 11th question of the book. Let me read out the question that I have written, not from this, as I read out. Sorry. Okay. So, let's read out the question. Two particles A and B move in a uniform gravitational field with a velocity with a acceleration g. So I think it's Earth, it's not Mars, it's not Jupiter, it's Earth, as the acceleration is equal to g. Or if it's not Earth, there would be any extraterrestrial planet out of our solar system. That's the question is given to. But we have mainly concerned with the acceleration g actually over here. So let's focus only on the Earth. At the initial moment, the particles were located at one point and move with velocities v1 is equal to 3 meter per second and v2 is equal to 4 meter per second horizontally in opposite directions. Find the distance between particles at the moment when the velocity vectors become mutually perpendicular. So I think it's an easy question over here. No question is easy or hard actually. If you don't understand the question, then every question would be hard for you, and if you understand the question, then the question would be a child's play for you. So let's focus on this question. Question from Earth, not actually from any other planet, as the acceleration over here is equal to g. So if both the particles at the initial moment at time is equal to 0 were, let be at origin, this is our origin over here, and one particle was moving with velocity 3 meter per second and one 4 meter per second in the opposite directions. So let me think about the situation when the velocities vectors become perpendicular to each other. So let's think about the situation. Both of them would be following a parabolic path over here. Both of them would be following, let me make it more clear, a parabolic path over here, as the acceleration is g over here. So let at this point their velocities were perpendicular to each other. So let this point be equal to b, this be at c. Let their velocities become mutually perpendicular. This is the perpendicular sign over here in time t. So as you have learned in vector algebra that after time t, what will be the velocity of particle B or A? So for particle A, vertical motion, we will get to know that its velocity Vy at final state would be equal to, the initial velocity was equal to 0 and acceleration was g, so it would be simply equal to gt. And for particle B also, vertical motion, let me write over here A, Vby would be equal to initial velocity perpendicularly was equal to 0, so it would be also equal to gt. So let me remind of few of vector algebra. After time t, what will the velocity of Va? After time t, velocity of A would be, the horizontal component would be not changing as there is no acceleration in the horizontal side of this question. Let me think about it. Where would it happen on the Earth? So I think it's an extraterrestrial planet where there is no atmosphere and there is no air friction over here, but the acceleration downwards is equal to g. So let's take out what is the velocity of A after time t. It would be simply equal to the minus 3 part in x direction, this is the unit vector I cap, and this is towards the negative side as like this, over here minus 3 plus gt j cap. This is the vertical side, and I have taken vertical side downward as positive, and for VB it would be equal to simply 4i plus gtj. As you know, the horizontal component would remain the same, as it is not Earth, it is an extraterrestrial planet, that I would say, and its Vy velocity after time t would equal to gt as we have calculated, and I have taken downward as the positive side, so this would be equal to that. And we know that if our velocities vector or any type of vector are perpendicular to each other, then their dot product actually would be equal to 0, as it would be cos 90 degree and it would be 0. So what would be the dot product of this over here? That would be simply equal to, I think you know how to get to the dot product. So here it would be minus 12 plus g square t square, which in turn is equal to 0, as they are perpendicular to each other after time t. So we get g square t square is equal to 12, t square is equal to 12 upon, let me take g is equal to 100, sorry, g is equal to 10, and 10 square would be 100. Taking g is equal to 10 meter per second square, write it over here, and t would be simply whole root of 0.12 second. So this solves our time part. So let's focus on this part. What would be the distance between particle A and particle B after time t? The distance would be actually the horizontal distance over here, as I am concerned. So the horizontal distance traveled by particle A from origin would be simply equal to 3 into the time taken to reach that point, and for the particle B it would be simply equal to 4 into time taken to reach the point C over here. So if we consider the situation that the distance would be equal to, I think you would be comfortable with this, distance would be equal to 4 into whole root of 0.12 minus, as this was minus 3, as this is left side and left side is negative of the x-axis, to 0.12 meters, and that would be our final answer. This distance would be calculated after solving this part of the question. And let me take out my calculator over here. Let me calculate what's the velocity, sorry, the distance. 4 into let me focus it more clearly. 4 into the square root of 0.12 equals this 1.386, actually 1.386 minus, let me calculate out this part over here. What is the square root of 0.12? Square root, sorry, is equal to this, and into 3 would be simply 1.039. Let me write 1 point minus, because there is a minus sign over here, and if we calculate it, we will get, sorry, 386 plus 1.039, and that would simply give us, let me calculate it to make it more precise. This work is 15, 8, 3, 11, 12, 4, 2, 2.425. 2.425 meter is a final answer, guys, and that solves our question number 11th of this book, this great book. This figure, I think, is my best figure so far. I think it's intuitive to understand what happening in the question. I've used dot product here, and dot product of two mutually perpendicular vectors is always equal to 0, and I've used this condition to find out the time t which it takes when their velocities are actually mutually perpendicular to each other. So that's solve our distance problem 2.425. I think you know that it moves this distance from the origin, the particle A, and this distance from that part, so there will be minus over here, and this is minus minus, and this will give a final answer that equal to 2.425 meters. Thank you guys for watching this video, and I hope you will press down the like button like this and subscribe to my channel. Thank you, and that's all for the question number 11 so far. Thank you.